So the problem is that he's going into double lambda here, and then when he's converting it back, then it's a double, and so it's naturally going to print 0.0. So what strategies do we have of dealing with this fact? We can do a number of things. We can have, let's brainstorm some methods here. Just say like, don't convert to a numeric type. Numeric type, and that's IE double or int. And just deal with, and just, let's say, add, remove a minus sign from the string, right? So you could hold the string, the raw string that you're holding. You just have a minus sign in front of it, and you have a method that would be like toggle minus sign, and what that method would be like this. In pseudocode, it would be check to see if there's a minus at the start of the input. So remove it. Pretty dumb, right? Else add it. So you can stay entirely in string land if you want. Method 2 might be to hold a Boolean as to whether the current value is negated. Right. So you can do that. What's the problem with that method, however? You can imagine if that were to play out. So I'm doing calculations, doing 1 plus 1, and then I get 2, and I say that plus 2, and I get 4, and I say, oh, I make that negative, now I have negative 4, and then I just do plus 2. Now I have negative 2. Right?
Yeah.
Right? And then I hit the negation, and then the Boolean flips, and it thinks it's negated, but negative 2 is negated, and it's now positive. So now I have this state mismatch, right, between what I'm doing and what I want to do and what I have. So it's not ideal. But it's still possible.
Yeah.
But you also probably have some string parsing to do. And so method 3 might be to do like this. Check to see if there's a decimal point in the string, in the input string. If so, convert to a double, else convert to an int. Right? And so up here, we actually have the ability to do, what is it, int value, I think? I hope.
Yeah.
Integer value. So now the decimal point goes away. Right? So what I could have done was check to see if there's a decimal point in there. And how do we do that? Yeah. Let me find that. I know how to do it.
Yeah, the only thing is, if you are doing a so method 3 is the most elegant, right?
Well, in this case, I think so. It's a little bit shaky. You have to be really. It seems pretty solid,
Right.
because I don't think there are any other cases where there would be a decimal, unless you have scientific notation, perhaps. But even then, I think you're safe.
Yeah.
Right? Think of any cases where that would fall apart. We're talking about the negations. We're talking about operations that try to maintain type. So if you type 15, and you're doing like a negation operation, you want to ensure that you get negative 15 instead of negative 15.0.
then it is method 3 technically.
Sorry?
It is method 3.
That's what you're saying.
All right.
Okay. So, did you go over checking for characters and strings at all?
There was a exercise for it, but we didn't go over that up to today.
There was an exercise for it? Where was that? When was that? In the string?
It was check to see if a particular string has a particular character.
Where was that? Was it in the, did you did? Not, I don't think we assigned that, unless that was part of one of the, Swift playgrounds, right?
Yeah, it was one of the playgrounds.
Okay. I can show you how to do that now. Maybe, did you show the iteration over strings on Tuesday? Okay. So, you can iterate over strings. So just like arrays. So the difference, so strings are essentially, are in principle arrays of what Swift calls characters. It's another primitive type called a character. And it's typically Unicode. So it's very difficult to index directly into a string because you don't know how big the characters actually are in terms of their storage width. So what you typically end up doing is having to iterate over the string, but there's a very peculiar technique that you have to use to do it if you want to count your way there, as opposed to iterating like this. So
In this case, you would just check for whatever block.
yeah, you want to check that value. So this
Whatever
value
value.
character,
Right.
you want to be able to check for that. But it's a type character, so you have to make sure that you have exactly what you want. So you can see here when I'm iterating,
Yeah.
it goes from there to there. So, and to get around this bug, I'm going to do this. So there, never mind. So it goes hello world all the way down. Okay. So on a clumsy way of doing this, is like this. Let's say I wanted to actually index into this. So there's some methods that Swift gives us that are essentially mechanisms that count for us across variable width things. So here I can say this. If I'm interested in getting the O, like the 0, 1, 2, 3, 4th character, I can do this. There's the O. Okay. So I think in that case it's actually coming out as a character, right? So the formatted way of doing this is to is. Maybe okay. Do you know of one?
Unfortunately, mine did it was back in December,
Yep.
and so maybe Hill Beta has, I know it has a lot more functionality for doing this kind of stuff,
Okay.
but I don't know if the latest version has those included yet or not.
Well, you might have to do. That's the way I did it, but I think that it's better to do this. Wow. Yeah. This is not going to help us. We want to be able to do it really, really directly and simply. Okay. Here's one way.
Oh, that worked.
I'm sorry.
That one worked.
This is a relatively inefficient way of doing this, but it works. It works in a way that's, for me, understandable. So their method. Okay. So Swift strings and NS strings also have methods that let you do this, like test for inclusion. So they're kind of, the behavior is just kind of awkward.
Do they return movement like move to?
No,
You know that?
no, they don't return anything useful. So, for example, if we're trying to test for the inclusion of the W in Hello World, so this is what happened. This is what it looks like. Oh wait, you can do that. Oh, we just found this. Look at that.
You need to do that in the future.
I think this is the way to do it probably.
That contains string.
Yeah. So
Oh, that's easy. So
this is
yes.
super easy. So these are the kind of methods that people are programming into and extending like the primitive classes with to make Swift more readable, and they're sticking in stuff like, and sometimes they're sticking in stuff like this. It's just that with this, you're creating a whole new object with that string, so you're essentially duplicating the data. If you're using really small things, it doesn't matter. So yeah, just do this. An S string is far more capable than Swift strings. But there are a bunch of method, like the value in this is learning how to iterate over strings yourself in case you're doing something like pretty fancy later on. But the key is these index methods that come with the string, so that you can, and the advanced method, which takes my string manipulation a little rusty. The reason why I gravitated towards this was in Calculator. I parsed the entire string myself. So I'm looking for matched braces and matched parentheses and crazy shit like that.
You have to do that.
So, yeah. So there's this really clumsy state machine that goes through and pulls everything apart.
Thanks, that was very helpful.
So the complete code that we're trying to get to, by the way, is this. So the challenge is, given a number, can I tell whether it's a double or not? And if it's a double, sorry, like let the number equals string, line value, double value, like negated equals negative number, like then number else, like number equals string my integer value. So does that make sense to everyone, more or less? If I have a double, I want to convert to double. If I don't have a double, therefore an integer, I want to convert to an integer. And of course, this is not playing nicely with us because we actually want it to print the decimal point. So we get out what we wanted to get out. So I put in 15.0, I get negative 15.0. I put in 15, I get negative 15 without the point 0.
So it sounds like you guys are recommending storing what's being displayed versus the value separately.
That's one way to do it.
We're not recommending. It's up to you to figure out. It's up to you to learn how to judge which is better or not. But it's one way to do it. I think last week I was holding. I think for the unit converter, I was holding a string that was the input value, and then I had a property that gave me the double value out of that. And I was always in double land.
Yeah, that's okay.
And then another way to augment that is to also have a property that's the string value. And whenever you update the string value, it automatically updates the UI label. Does that make sense? I think I did that once when I was playing around with it. So here in the view controller code, sorry.
Maybe like updating the display label.
Yeah, so I have these stateful methods that update the display. Update buttons, update input output value. So conversion event handlers. And so these guys update output display, update units. So you can actually have a property that has a getter and a setter for the input value. So instead of this piece of state that we have up at the top, which is a string, you could have a property that looks like this. What is it? This just again. I'm not running on all cylinders today, guys.
You don't need to pass value anymore instead.
I'm sorry?
said you no longer need to pass a value.
Yeah, I just.
Or just say set.
Yeah.
Say set, and then
Nice.
new value is accessible.
This new value and old value are accessible within that block.
Like this.
Yep.
Nice. So you can do this, and whenever you set this, what I've marked as private, so that's going to be the implementation sitting behind this property. Now I can call a method to update the UI label here. So then the UI label is always synchronized with whatever that value is.
Yeah.
Right. So I don't have to worry about it anymore.
That's one approach.
It's one approach.
But
It's
that,
one approach.
that'll break it up.
I'm sorry?
I said that will break it up.
If I only use this, and I never ever touch this, it should be okay. Right? If I only ever use this, see what I mean?
What's input value? What's on the screen?
Yeah, this is intended to be what's on the screen. So if I'm doing a strict separation between my UI, my view, and this guy, which is my controller, and then this guy, which could potentially be held in a model somewhere, which is like a converter engine, then now I have
That's where that's what I mean is separated into that way.
Yeah. So we haven't talked about design patterns yet, but
We did a little bit.
yeah, you did on Tuesday?
A little bit, yeah.
Yes. That's good.
Is this something we've been using? Is this something that we haven't given a name to?
That's right. So did you talk about MVC or delegation or?
Not litigation, just what MVC was. As we were reading the requirements, they, the midterm project mentioned use a couple of words that we hadn't really defined 100%.
Yeah.
This is based on something we were doing, and we just didn't have a name associated with it.
Yeah.
Can you switch back to the playground before?
Oh, sure, no, sure. Okay. So I think what we want to do today is Angel and I are going to check in with all of you. We're just going to work on the project for the next, let's see, until about 8:45. So that's about 90 minutes. And then the last 45 minutes, we will get to a point where you should all essentially present to each other where your project is at the moment and what challenges you've encountered, and like what were a challenge you've encountered and what approach that you took to solve it. Okay. Does anybody have any questions about Swift classes or any other topics that we've gone over? Anything you've encountered and like Googling stuff online that was unfamiliar that you'd like to know about, you think might be useful? There are two concepts that were in the unit converter that we hadn't gone over before, tuples and enumerations. I think I might briefly talk about what those are, unless you already know what they are. Not familiar? Okay, good. So Xcode's crashing, so give me a minute So two new concepts, enumerations and tuples. An enumeration is a shorthand for it's kind of for a tagging mechanism. It's like a way of using words instead of integers and numbers and strings in order to indicate something like a set of tags or a set of options or a set of modes in your app. They're implemented as integers by default, but it's simply a way of being able to make your code essentially more readable. So the example that was in the unit converter used an enumeration to give you the difference between two different conversion modes, imperial to metric and metric to imperial. So the way that enumeration would be defined would be something like this. So use this keyword num for enumeration. And then you need to give it the name of the category of things that you're talking about. So in the app, it was something like conversion mode. That's a name that we chose arbitrary. It's almost like a class name. You're not defining the class at all. And the way that we define those two modes that we're interested in, imperial to metric or metric to imperial, is by using this keyword case. Like that. And that's it. It's mostly just words. It's like defining a set of tags in Evernote or like a set of tags in Evernote or any other app that uses a tagging mechanism. So now that word convert. Angel, could you shut the door, please? This is, I don't know, someone is fighting with tissues. Alright, thank you. I can't hear myself talk to you. So now that can be used as a type. So for example, I can have like current mode and give it conversion mode. And then set it to one of these two modes by using dot notation. Like this. So what this says is that this variable will hold any of these cases that's defined inside that enumeration. And then what I can do is set that value by using to one of those cases by using this weird like floating orphaned dot notation. And then run comparisons using that dot notation as well. Now this kind of orphaned dot notation is shorthand. And the reason why Swift is able to give us that shorthand is because it knows the type of the variable on the other side of the comparison symbol, on the other side of the double equals. So this is actually entirely equivalent to this. It's exactly the same. But Swift knows that it knows what the enumeration type should be, simply because of the fact that this was declared to be a conversion mode.
So is that a dot or sorry?
It's a dot. These little guys right here, that's a dot.
But if you change that variable to dot, metric to imperial, then they flip-flop, right? Or no? The true and false.
That's right.
Yeah.
It's just like any other value. You could imagine this being an alias for 0 and this being an alias for 1, 2, 3, 4, 5, 6, just like kind of like that. If that helps. It might help. So, like another example might be units, and we could say feet liters, I don't know, ounces, grams, miles, kilometers, etc. So you can use this to start to define a set of tags or set of working words that make your code much more readable. This is really useful to keep track of things like units or things like states of your app. Like, has the user entered a number? Has the user typed one of the arithmetic keys on the keyboard? That kind of thing. If you're using a modal technique to describe the state of your app, like what stage in the workflow the user is in. Okay. So let's use this example for a second. So I'm going to say is metric. I'm going to define a function called isMetric that accepts a single variable whose type is this enumerated type. And it's going to return a Boolean. And so what I want the behavior to be is if I give it feet, it's going to return false. But if I give it meters, it's going to return true, etc., etc. So there's a way of dealing with this kind of thing, this kind of scenario that lets you sidestep having to write a giant if-else statement. And that construct is called a switch. Okay, so it's going to fight me on the indentation, but I think it's...
So you could just use this for our case what we're working on. You could just do this for the operators.
Yeah, good. So in terms of the... Oops. I think I actually have to do this explicitly. It's questionable whether that's correct, whether this is the right behavior or not, but... Okay, so what do I miss? Oh yeah, dang it. Sorry guys. Oh man.
I was doing that. I kept writing in JavaScript
Yeah.
Tuesday.
Oh, did you really? It's the handicap of knowing multiple languages. Sorry. So then you can say is metric, units dot feet. I think you can just do dot feet actually. It's false. Okay. So does this make sense? This switch clause defines a kind of like linear set of if statements where it's going to take whatever this value is and check it against all of these different cases. These don't have to be enumerations, they can be any value that you want, anything after a case. So it can be a set of strings, it can be integers, whatever. So for the arithmetic operations, you could have an enumeration or like operators, and you could say case addition, case subtraction, like this, right? Et cetera, et cetera. Like you could use that to make your code a little bit more readable if you want. this right here is a very common pattern that you see. So enumerations are also important because a lot of UI code uses enumerations to determine options in views. So I'm trying to think of one.
UI alert.
Sorry,
UI alert.
UI alert.
The new one for the styling of the buttons and the style alerts. Oh wait,
I think
that's a playground. Bad choice.
This is a playground. Is that not going to work well? If I do UI kit and call it, is it going to freak out?
Should it? No. Will it? We'll find out.
This is the new way of doing this, right? Okay, so there's a third argument to this, which is of the enumeration UI alert controller style. So here are the two different values that I can set that are part of that enumeration action sheet and alert. So in UIKit, these are scattered everywhere. Sorry, keeps jumping around. In UIKit, these are scattered everywhere. So anyway, I would show you how this works, but I'm afraid to. Without having to present it as a view controller. Okay. So you'll see this scattered, you'll see this kind of thing scattered everywhere once you start dealing with views programmatically. Okay, anyway. Any questions about these? It's just kind of icing on the cake, really. This is not critical path to getting the calculator done, but it's a nice thing to know, and you're going to see it more often in the future. All right, tuples. Tuples are awesome. Tuples rock. Tuples are my jam. So tuples are a way of grouping values of different types together in an immutable fashion, a very structured, linear, immutable fashion. So it's kind of like an array, but instead of an array being, with an array you're talking about a bunch of elements of a particular type, usually an array of double, an array of integer. With tuples, what you're going to say is, I have a tuple of an integer and a double. Or a double and a double, or a boolean and a boolean and a double and a boolean, and then that becomes a type by itself. So
for those, you always have to pass two different, what if they choose same or two different types? How would we define that?
yeah, it mostly depends on the context, but yes. So, for example, let's say I wanted to return, let's say I had a function and I wanted to return more than one value from that function. So like I'm trying to do something that's not math, but I think I'll have to do something that's math. Like a complex number is immediately what comes to mind. Oh well, we can continue with our theme of units and say first of all, that's what a tuple looks like. It's a comma-separated list that's delineated by parentheses. Okay? So in this case, the tuple itself has one element that's the number 12 and another element that is the Boolean false. So I have this funky syntax here that, yeah, lovely, isn't it? So dot 0 gets me the first element of the tuple. Dot 1 gets me the next element of the tuple. So instead of using brackets like you would with an array, you have to use dots. So those essentially look like methods even though they're not. So the type is tuple of, double, and Boolean. So we can actually redefine this using this.
Do we have to?
Nope. No, it's implicitly typed. But you have to learn this syntax always because if you use it in a class, you might not initialize it right away.
Yeah.
Right?
Yeah.
Okay. Tuples can have names. You can take each element of that tuple and give it a name just like arguments in a function. So here I can say like this. All right, that might be a little over the top, but we have the first element of the tuple is name. It's called units. It carries the type of it carries our enumerated type units, which means when I actually define the tuple, I have to include those names. So the first name would be units, and then dot feet is an example. It's one of those enumerated values that's inside the type. And then this metric is my next name. It carries type Boolean, and so I'm going to give it a value that's a Boolean, which is false. Now, instead of using dot 0 and dot 1, I can use the names to get those values out. So dot units, or dot is metric. So these types are all collected together. The type itself is this collection of multiple types. It doesn't have a name though, right? It's just a generic tuple that happens to be defined by the fact that it's a units type and a Boolean type together. So it's a little bit more abstract conceptually, but there are a number of cases where you might actually want to return multiple values out of the function. And you can do that using tuples. So let's say mathematically if I had a function that did division for me and it gave me both the answer and the remainder that came out of it. I don't know if that's confusing. So let's say I was making a calculator that was for kids learning about division, and they were trying to learn about this notion of a remainder, and I created a convenience method for myself that returned both of those values. Like the actual answer of the division, and then the remainder that came out of it. In the spirit of readability, I recommend you always name your tuples, just because it makes things much nicer, much more readable. Like enumerated types and tuple and named tuples together can really start to feel like Swift is starting to become more like friendlier in terms of readability. It's more verbose than other dynamic language. It's more verbose than dynamic languages like Python, because you're putting types in, but it helps you so much in knowing what you can do at any given moment to a given value, especially when you start to deal with classes. It's like intermediate Swift, guys. This is starting to get real. Wait till they get to metaprogramming.
Into the program?
Metaprogramming. That's where you start to call, functions by name, using values. So sending selectors and stuff like that.
Oh, just done that.
Yeah, let's do it.
Let's do it.
So here, X and Y.
Yeah, those are my arguments. Actually, those, I think, and Angel might know better, but I think that the arguments for functions are actually defined as, are actually implemented as tuples. So this guy, it's not a coincidence that that looks like a tuple. That this and this actually look exactly the same. But that's just a hunch. I haven't actually looked at it. In my last start of the programming language that we had, that was exactly true. Like we had a type that called tuples that could be named, and our arguments were implemented as named tuples.
Wait, what? So you can so you're telling me that you can create a series of parameters, name that series of parameters, and then pass that to a function?
I don't know if you can or not.
No, I mean in the language that you...
In ours, yeah, totally. You could create a tuple, and then you could star that and pass it in as the arguments for that thing. So you could programmatically construct your arguments and then pass it into a function. Oh yeah, totally. And it worked on a principle of pattern matching. So like the arguments themselves were this functional pattern match, like a big switch statement. So you could actually have multiple clauses for your function bodies. Like you could give a function 5 function bodies and 5 different call signatures, and it would do it. And it would dynamically execute it and compile it and distribute it across a cluster. So it's fantastic.
What language is that?
Sorry?
What language is that?
It's called Fora. If you're interested in reading about that language, Just the other day, I heard that they were able to implement. Sorry, let me get my workspaces set. That they were actually able to run a giant matrix multiplication on, I think it was 4,000 cores all at once, and all they had to do was type. Look at this. The language is even simpler than Swift. It's like a little tiny chunk of code. So if you're interested, kd.euphora.com. This is the language here. I wrote most of this, actually. So functions look like this. They're first class values. You can create, like, there's one that tests for prime numbers. You can add multiple function bodies somewhere. Where is it? So they're named tuples right there, just like in Swift.
This is a really broad question, but is like the logic pretty consistent across languages? It's just syntax and.
There's syntax and semantics. So, for example, Ruby, you can't pass around functions like values, right? So there's certain restrictions and like conventions and meaning that are different from language to language. Also, there are implementation concerns and different side effects that various languages have. Like in Swift, you have let and var, right? So you have constants and variables. In Fora, you only have let, so everything is constant. But the way that those are treated, it doesn't mean that you can't change the value. So it's treated like a variable, but it's optimized like a constant. So whenever you're executing a chunk of code, it knows at any given moment that computation is deterministic. So that lets us do things like serialize the computation, move it to another machine, and pick up where it's left off, stuff like that. So anyway, that's beside the point. Okay, that's it. That's all I got. Enumerations and tuples.
So helpful.
Okay, good. All right, folks. So from now until pretty much. If you haven't yet slacked whether you can make it to happy hour or not, please do. And yes, we can go early, but please do because Daniel still has to set up the tab at the bar. Angel, could you let Daniel know?
I'm communicating with him right now.
Oh, sweet. Question?
Just whenever you get a chance.
Okay.
No rush.
Is there something everyone else can benefit from?
So, my last class, I was here and did the dog app. So, I don't know, because I wasn't here last Tuesday, Thursday, last Tuesday.
Yeah.
It's just been, I had to fly back to Milwaukee, move my dad to
my example code is, I think my example code is posted.
Okay,
So
cool.
for mine, so you can probably.
I just wanted to know that that's where I was, so that wasn't an error on my part, that was just something that.
That's right.
Okay.
And you have all the tools to do it already.
Yeah.
So the Segway, has access to both view controllers. In the target view controller, you just have to store a value that's the dog type. So you grab the dog,
Okay.
and then you
Yeah,
just
so
set it in the new view controller, and you're done.
Okay, cool. So it was just, for whatever reason, I didn't know if it was an issue with this, like, any object, but this is all on the lesson plan, so I can figure that out on my own.
Yes.
Um,
Yeah, so this is stuff that comes from the example of master UI table view controller. So we did an example that actually did away with the table view controller.
Okay.
You can continue doing it this way, it'll work fine.
Okay.
But there's a different technique that uses protocols, where you use a standard view controller, you add these protocols to it so that it now is empowered to control a table view, like a raw table view, and then everything else is the same.
Okay, so that was the last.
Yeah, that was like 2 steps.
Okay, so then the next Thursday was then, I'm assuming this was.
Yeah, the units conversion.
Okay, so I just want to make sure I get caught up as to.
You should watch that video, or that set of videos.
Okay, so that's why I just downloaded those. So that basically speaks to where we're at now.
Yeah, that sets you up for this.
Okay.
In fact, it's almost a cheat. It's like almost giving you a cheat sheet for the midterm.
Okay, and the midterm is.
Midterm is a calculator, so it's under projects.
Okay.
Midterm.
Gotcha.
Yeah, mid-course project.
This guy.
Yeah.
Okay, so
It's
that's.
just to mimic the calculator app on iOS.
Okay, cool.
Um,
All right. I just didn't know if there was anything else that was integral between the dog and the table.
No, it's the lesson right before my table stuff was table views. And then the next one was supposed to be this other lesson that we're going to do later. Okay. And I said, all right, so the thing that we're going to do now is I'm going to walk you through this units conversion app. Because we've been talking about unit conversions since day one, practically.
So I should just basically refresh myself through those two videos.
Yeah.
Last Tuesday and last Thursday.
Yes. And this leads right. The unit conversion leads right into this.
Cool.
It shows you how to do the UI. It shows you how to save.
All right. Well, then I'm fine. Okay. So that was all. I just wanted to make sure I was ready.
Is that you?
That was me. Oh, jeez. All right. Okay, cool. Thank you.
Sure. Appreciate it. Fine. So it's just got, so the UI comes out, and it looks like that. So now you're dealing with, buttons. Think of value in this case, like we have said when we were doing the unit conversion, we said one of the value was the value that the user had put into the calculator. So probably the hardest.
So while the
computer
training
science
is already
naming,
embedded in the
it's
application,
going to be it's not
while you're
it's isolated to any individual. Everyone struggles with this, even for like professional engineers. So
you move
in your mind, you can find a better name for that stuff.
You're not iterating.
You should do
operator,
make that
Yeah.
like.
but you need to make sure that you keep track of
The operations.
don't clear it from the stack, but like keep the stack the way it is.
Yes. And I guess first for clear display that I call it sender button, but I should create because I want to call it sender first.
Could be.
And let's get the problem right.
It doesn't matter. The sender button doesn't matter.
The one way,
Keep it there
Yeah.
and I can still call it.
another way to approach this.
Oh, you mean going from?
Is to say,
Oh no, yeah, you want to take it out.
I have,
Because then you're not sending sender.
now what I want to do
But then I have to
is
write
write
wire that.
Yep, that's one of the things that I saw.
words. What are the interactions that I have to, I'm going to embody with this?
So
User wants to multiply 5 times 7. So what are the actions?
How are you?
Tap on 5. Tap on
Did we already bother you?
Tap on
No.
7.
Okay, so I'll bother you.
Display changes to
Pretty much just kind of like I built like the initial interface or whatever.
Let's see the interface.
But I'm pretty much just going doing more like
For example, the percent sign we
call the pseudocode of
That's
how to think about it.
That's a good approach.
It doesn't mean you can't change. It doesn't mean that
But I'm
the
still working in
approach
the middle of that.
writing the class for these
I mean, my
restrictions.
biggest problem I think is just like, I mean, everybody's probably just like building up the actual infrastructure. So I figured if I do it this way, you just try to think about what is needed for each button, and then I can just go back and reference some of the precedents. And try
Before
to
you
build
do
it
that,
from there.
you and I need to sit together because the way you're doing it, you are already extrapolating the model so that you don't have to copy and paste everything in there into your view controller. So if you're doing it in playgrounds, you could literally take your entire playground, turn that into a class, slap it in there, and then have your view controller call those functions that you're going to be defining here.
Okay.
So
But we can do that together. If you want to have it working conceptually in the playground first,
Yeah.
and then worry about I mean, you already have the design. You want to worry about the wiring together later.
Yeah.
That is a good approach. That's actually how I did it.
Okay.
But